Hey guys, today we're going to be continuing our look at systems of equations, but today we're going to talk about some nonlinear examples as well. So we've been covering some nonlinear examples such as circles and parabolas. Now, when we solve these, you notice I kind of circle them to make a little bit more point of emphasis. We might have more than one solution. Notice there's two solutions on these three examples. This also illustrates one way of solving, graphically. Now, we're going to focus primarily on our algebraic method of solutions, so that would be like specifically using substitution again, but graphically can be used to verify our answers as well. So let's jump into some examples here. Now, before I continue this two-circle example, you're going to see that on the notes, but you're not going to see that on the homework. We're going to say that as kind of a bonus or an extension problem for you guys. See if you want to challenge yourself with that. All right. Now, over here we have a circle and a line. My vertical line x equals 5, I underline that, try to draw your attention to it. X equals 5. If we know what a variable is equal to, then we should use it in substitution. So let's substitute this x equals 5 into our circle equation. Now we're still going to have to solve for y, right? But simplifying, 5 minus 2 is 3, and 3 squared is 9. Y minus 2 squared equals 16. Pay attention, we're going to solve this. I don't really need we will have to do some binomial multiplication, or sometimes you guys refer to as foiling. I will have to do some expanding, but not on a problem like this. I'm just going to subtract 9 from each side and get y minus 2 equals 7. Almost forgot the square there. Now my next step is to get rid of this exponent. So I'm going to need to take the square root of each side. Now pay attention when I take the square root. I am now left with y minus 2 equals positive or negative radical 7. Now there's a reason why we have that positive or negative there. Whenever we're solving in an equation and we take the square root of each side, we should always put a plus or minus there. The square root of 7 could be positive 7, or could be positive or negative. A root has a positive or negative root. So we have those two answers there. And this is going to lead us to the two answers when we solve. We get y equals 2 plus or minus radical 7. This leads us to our two answers, or the 2 points of intersection that this line has with the circle. The points of intersection are this. Remember, we are looking for ordered pairs. My x-coordinate is 5 from that vertical line x equals 5. My y-coordinate is 2 plus radical 7. This is one point of intersection. My other point of intersection is 5 and 2 minus radical 7. These are 2 points of intersection. Both of these are solutions to this example because both of these, they are intersecting with one another. If you look back up to the example, see how this point of intersection had the same x-coordinate but then two different y-coordinates. That's exactly what we're illustrating right here. This vertical line has the same x-coordinates but different y-coordinates at the two spots of intersection. All right, let's continue on and look at some other examples. Now, as we're solving, we have a circle and a line again. Now, we can plug this negative 7 in just like we did in our first example. So, let's plug in negative 7 for x. Now, when we solve, we're going to have negative 7 plus 3 is 4, and 4 squared is 16. So I'm doing some of the math with mental math, as I would expect some of you guys are doing as well. But by all means, you can write that step out if you need to. Now we have 16 plus y minus 2 squared equals 25. Subtract 16 from both sides, and we get y minus 2 squared equals 9. Now I'm going to take the square root from each side. We get y minus 2 equals plus or minus 3. Remember, the square root of 9 could be positive 3 or negative 3. Y is therefore equal to, adding 2 to both sides, to plus or minus 3. Now that's two answers, so we're going to separate that into two answers in a second. We have 2 points of intersection. We have negative 7, my x-coordinate, and 2 plus 3, which is 5. We also have negative 7, 2 minus 3, which is negative 1. These are 2 points of intersection between that vertical line x equals negative 7 and the circle given by this equation. Now down here I have the question, is x equals negative 7 tangent or secant to the circle? Review our vocabulary real quick. Tangent, you might want to jot this down somewhere, means one intersection. Tangent means one intersection. If you're tangent to something, you just touch it once and kind of skim off the surface. Secant to the circle, 2 intersections. So we kind of already know that we have 2 intersections. That would imply that x equals negative 7 is secant to the circle. It just means it intersects the circle more than once. Right? It almost forms a chord through the circle. Now we have an example of a parabola and a line. We're going to look at a graphical representation of this as well. We're going to use the substitution method to solve. If I want to figure out 4y equals x squared, which is a parabola, and the line y equals 1x. Now, eventually the graph, I'm going to put this in the y equals format. But it doesn't matter if I put this in the y equals format now or later. Right? Really does not matter. So I can solve this without it being in y equals format because I have y equals 1x. Therefore, I can substitute into this equation. Right? I can substitute 1x in for y. And now we have 4x equals x squared. Remember your rules from Algebra 1. You can't square root or anything like that right now. We're going to minus 4x. We have 0 equals x squared minus 4x. From there, we're going to factor and solve. Notice the GCF that we have here. We can take out an x from each side. From this side. X minus 4. Now we can apply the zero product property, meaning I can set both my factors equal to 0 and solve. Well, x equals 0 is already solved. If x minus 4 equals 0, x equals 4. Here are my two solutions. I have x equals 0 and x equals 4. There are 2 coordinates where this line will intersect the parabola. We have the x values of the coordinate. Now let's go ahead and find the y values. To find the y values, we have 2 options. I can take these x values and plug it into my parabola or into this line. Let's think about why we can use either one. The coordinates or the ordered pair will be the same on the parabola or the line because those are the spots that they share with one another. That's why they're intersecting there. They share those coordinates. So naturally, I'm going to use this equation since it's a little bit easier for me to work with. Y equals 1 times 0, which is 0. So I have an ordered pair of 0, 0. And y equals 1 times 4, which means y equals 4. So my ordered pair is 4, 4. So here are my 2 solutions. In order to graph these 2 solutions, we would go over here to illustrate that. So the graph, my line y equals 1x, well, that's just a line with a positive slope. Yep, y equals 1x. Hopefully you guys got a ruler or a straight edge readily available to make that maybe a little bit neater. If I want to graph this parabola for y equals x squared, it might visually help. I'm going to write over here. Some of you guys like to see it maybe into the y equals format. X squared over 4. Now, to come up with some ordered pairs here, you might want to use a table of values to help you out. that's certainly a good method. So I could use something like 0, 0. Now I'm doing this one just a little bit quicker because our graphing is not my major point of emphasis for parabolas, but I can use a table of values, that 0, 0 is an ordered pair. I can also use a table of value, and I'm going to cheat a little bit because I know 4, 4 is on there. I'm going to try 4 out. Well, if I plug 4 in, I would get 16 over 4, which is 4. I also know that parabolas are symmetrical, so if I plug in negative 4 into this equation, I should also get the same value of 4. So even though it's a little out of order, if I put in negative 4, I'm also going to get 4 as well, because parabolas do have that symmetrical nature to them. So my parabola is going to look something like this. Notice that 2 points of intersection, 0, 0 and 4, 4. Okay? Our last example we're going to cover today is another circle and a line. This was just a little bit differently because I didn't make a vertical line. We made just a regular line that you expect to see, right? With slope and a y-intercept. So we're going to take this y value and substitute into the equation. X plus 1 squared plus x minus 3 plus 2 squared equals 16. Notice I replaced the y, what I'm underlining, with x minus 3, or what y was equal to from the other equation. Now, solving this, I'm going to have to do some foiling or binomial multiplication. It might help visually to know that this reduces to x minus 1 squared. I'm going to expand both of these parentheses. So we're going to do x plus 1 squared and x minus 1 squared. So x plus 1 squared is x squared plus 2x plus 1. Now you might want to take your time, pause, and do some of the side work to do that multiplication as well. X minus 1 squared is x squared minus 2x plus 1. Now, to finish solving this problem off, I'm going to combine my like terms. So, combine my like terms. X squared plus x squared is 2x squared. 2x plus negative 2x is 0. So they almost cancel each other out. So I'm going to just cross those out there. 1 plus 1 is 2. Now we're going to factor and solve. Well, notice I got 2 in common here. So I might do something like this. 2 factored out. I'm going to move up to the right hand side. I can divide each side by 2 now. See how I factored out a 2 because I have a GCF in common. So now it's factored out. I'm going to divide both sides by 2. Leaving me with x squared plus 1 equals 8. From there, we can subtract 1 from each side. We get x squared equals 7. Well, you guys know what we got to do for our last step. We got to take the square root. We get x equals positive or negative radical 7. Those are two x values referring to two ordered pairs, two coordinates. So that's just the x values. To come up with the y values, we would go back into, now you can use either equation, but my linear equation is going to be the easier of the two to work with here. So my ordered pair is going to be positive radical 7 and negative radical 7. And the y value comes from plugging into this equation. So I'm going to have, if I plug in radical 7 up here, I can't simplify this. So it's going to be radical 7 comma radical 7 minus 3. If I plug in negative radical 7, I'm just going to get negative radical 7 minus 3. I know it looks a little weird, but this is a number. Now we could come up with a decimal equivalent of that number, and in some cases we might need to. But very often you're going to see us say, just leave it in radical form or leave it in exact form. Anytime we start getting into decimals, that becomes an approximation. Okay? So those are the exact 2 points of intersection. Now there is one more problem, 2 circles. I'm going to leave this one as a bonus question for you guys. It is optional. You do not have to complete it. There is not a question like that on the homework. But it is solvable if you guys want to take a crack at it. I will wait a little bit and I'll post the solution to that problem later. Okay? Good luck.